So you want some excitement in your life, huh? Well, I surely hope you do, because JavaScript is like a crazy fun ex-girlfriend, but with a lot of crazy and with almost zero fun. Even if it sounds like an unbelievable idea, this silly little language ended up being not only the default solution for web development, but also a really viable option to build mobile apps, backend systems, and even machine learning algorithms. In the next few minutes, we'll review the reasons behind JavaScript's popularity, so if you are planning to learn it, or you just want to simply make sure you have all your basics covered, this video is a great place to start. To make sure we are all on the same page, let's dive into a bit of history. JS was first released in 1995, when Netscape hired Brendan Eich to add a scripting language in their browser. It was famously built in 10 days, which is close to the amount of days God itself needed to build the entire world. If you ask me, this was pretty rushed and the results are far from perfect. JavaScript has quite a few bad parts as well. For 15 years or so, JS was this tiny thing used to write silly scripts in the browser. Then, in 2009, the ecosystem took a huge step forward with the release of Node.js. This marks the beginning of JavaScript as an established language, and it was now acceptable for devs to move JavaScript from the hobbies section to the skills section in their LinkedIn profiles. The 2010s brought a bunch of releases both in the frontend and in the backend space. UI libraries like React or Angular, and backend frameworks like Express or Nest.js are all built on top of the performant, reliable JavaScript. During this time, the community rushed to adopt TypeScript, arguing types are offering a way better developer experience. This was actually a failed attempt to wash away some of the shame caused by making JavaScript the most popular language in the world. You are not fooling anyone, TypeScript. We know what's behind you. At the end of the day, TS is still compiled to JavaScript, which still remains the main programming language of all modern browsers. Coming back to today, JS is trying to do better and follows an yearly release schedule with a predictable 5-stage system for its new features. The main decisions are made by the TC39 committee, a group of professionals from various big companies involved in the future of the web. Okay, next, let's spend a few seconds on the actual JavaScript language. And I'm not exaggerating. JS is so simple and has such a low barrier of entry that we just need a few seconds to review all its core features. To start, we can simply write some code in a file ending in a .js extension and then import this script in an HTML file. Another option would be to execute this code directly in a terminal using Node.js. We can define variables, constants or functions and pass them around when needed. JavaScript implements a few functional programming concepts, among the most important one being its support for first-class functions. JS also supports object-oriented programming, and you can define classes with constructors, static fields, and private members. You can then create objects based on these classes, or simply use object literals to create the structures your program might need. A big distinction compared to other OOP languages is that JavaScript objects are built on top of the prototype mechanism, which makes inheritance a little bit different than what you might be used to. One thing's for certain, JavaScript code is extremely easy to read and understand. It follows the very popular C-like syntax, with few keywords and with all the memory management abstracted away for you. This code is executed by the JavaScript runtime, which uses an engine such as the Chrome's V8 or Mozilla's SpiderMonkey to convert JS into machine code. The engine itself consists of a memory heap and a call stack. The heap stores all the variables defined in our code, while the call stack is in charge of keeping track of the function's execution. JS is single-threaded and uses an event loop to monitor the stack. Whenever the stack is empty, the event loop checks for any additional work in the callback queue. This architecture makes JavaScript asynchronous and non-blocking. This is a fancy way of saying that whenever the runtime has to wait for a long-running operation, like an HTTP GET for instance, the code depending on that response will be added in the callback queue, and the runtime can continue its work until the response is available and the stack is not occupied with some other task. Sounds complicated? I agree. So JavaScript might not be that simple if you don't have a technical background. Don't worry though, we'll look at an actual example in a second. Besides the engine, the event loop, and the callback queue, JS runtimes also offer a large set of web APIs you can use to achieve various tasks. This is how you can interact with the DOM, geolocate your users, or retrieve information back from the server. All these things are working together when your code is executing. Let's review this whole process by looking at an example. I'm defining a simple callback function which fetches some user details and populates them in the DOM. When the user clicks on the button, the callback is added in the queue. Then, when the stack is empty, the event loop will move the callback from the queue to the stack. The code will be executed line by line, and when the fetch details function is reached, a new entry will be added to the stack. Inside this function, we are making a call to the server using the fetch API. The request is being triggered and, at this point, the runtime doesn't care about its execution thread anymore. It pops the fetch details function of the stack and returns into the populate details function. Here, the callback code will be ignored because it relies on a server response from the web API container. This callback will be executed only if and when we'll get back the response. Then, the populate details function is popped off the stack, and now that the stack is empty, the event loop can delegate more work. Next, let's assume a few seconds passed, and the fetch API call finished its execution with a successful result. At this point, that callback code that was previously ignored is pushed to the callback queue. The queue is a first-in, first-out data structure, so, of course, the callback will not be executed immediately. However, when its turn comes and the stack is empty again, the callback will be moved to the stack, and that code will be then executed following the same process we already described. Ain't JavaScript fun? Bear with me through this ordeal a little longer, while we talk about a couple of changes aimed to improve the overall experience of writing JavaScript. So, as I said, JS scripts started small but are now powering entire full-stack applications. In order to help you structure this code in a sensible manner, you can use JavaScript modules. Modules enjoy wide native support in browsers these days, but it still is fairly common to use tools such as Webpack or Vite to bundle your JS code and prepare it for production. These tools also allow you to do transpilation, which is the process of rewriting JavaScript functionality not yet approved by the TC39 committee or not adopted by the browsers, or compilation of languages such as TypeScript into plain JavaScript. Finally, as I hinted multiple times in this video, you are not tied to the browser when working with JavaScript anymore these days. You have your extremely popular Node.js, but also some other more recent powerful alternatives such as Dino or Bun. All these are pushing forward the JavaScript ecosystem and are contributing to the popularity JS has across the entire development space. If you found this video useful, please click the like and subscribe buttons, and until next time, thank you for watching.